So hi, today we are going to be solving Cambridge IGCSE Chemistry Paper 6 Alternative to Practical February-March 2025 and Paper 62. Okay, so ATP papers basically have a repetitive pattern. I'm going to tell you again and again that in ATP paper, if you have a strong practice, you have a strong grip on the type of questions that come, because the questions that you're going to see, they're going to be repetitive. They're going to repeat again and again. एक ही question को आप बार बार देखोगे different types में. अब देखें ये वाला question है chromatography का. अब same mistakes every time you're going to see. Either it's going to be the lid should be up or something like this, the same mistakes that the baseline has to be drawn with a pencil or something like this. So the mistakes and everything that they ask in an ATP paper, they're repetitive. Okay, either you're going to get the question from chromatography or from titration or from an exoendothermic reaction. So अगर आपको एक दफ़ा ATP के पेपर की प्रैक्टिस करने की आदत हो जाए ना, अगर आपको पता चल जाए कि कौन सा क्वेश्चन कहाँ पे है, how the questions come in order, it's going to be very easy for you. So identify two errors the student made. Okay, the first error that we can see is that the ink spot, the black ink and the purple ink, the ink spots, they should be on the baseline. As far as I know that in chromatography you put your spot on the baseline, but over here the spots are below the baseline. So the first error are that it should be that ink spots are below the baseline. And why is that you have to put the ink spots on the baseline is because when this water is going to move up and your spots are also going to move up, they're going to travel up. But if your spots are not on the baseline, you cannot calculate the distance they traveled. Okay, so if you put the spot exactly on the baseline, then you can calculate how much your spot traveled by exactly measuring with the ruler from here to here. Otherwise you won't be able to measure accurately. Okay, and the second error which we can see is that the level of water or the solvent is basically below the chromatography paper. It should be some below the baseline, something like this. Okay, why? Because look, how can this chromatography paper now soak up water, and how can water move up? It cannot. So the second error is that level of water is below the chromatography paper, is below the chromatography paper. So that's the second error, because this now basically what will happen is that the paper won't be able to soak up water, okay? Because the distance you can see from here, obviously water cannot travel through air and then soak up into the paper. That's not correct. So if it was here, then it would easily, the water would move up the paper. So these are the two errors. State the name of the equipment used to draw the baseline on a chromatography paper. It's a repetitive question. They always ask that how do you draw the baseline. You should know it, that we always draw it with a pencil. Okay, never use ink pen or pen. Why? Because pen itself contains ink. Okay, pen itself contains ink, which is a mixture of dyes, so it can interfere with your chromatography. Okay, the student corrects the errors and then carries out the chromatography. The chromatogram in figure 1.2 shows the student's results. Identify an ink. Okay, I love this question. This question is really good. So I'd like you guys to tell me the answer to this part. If you consider yourself really good, not at chemistry, it's just general knowledge, it's common sense. Identify an ink which could contain only one colored dye. Okay, these are the dyes which we can see. This dye, these are all the dyes which we can see. Okay, these are dyes. So we have to identify an ink which only contains one color dye. I guess it's obvious that it's going to be yellow ink because it only contains one spot. Deduce which ink could be mixed with the blue ink to make black ink. Okay, to make black ink, basically to make black ink, firstly we need three dyes. Okay, we need three dyes. We need a blue dye. This one is a blue dye. How do I know? Because look, this is only present in blue, so this one is blue dye. This one and this one, these two are some other dyes. But if we mix these two dyes, try to understand this. if we mix these two colors with the blue color, this is the blue color, we can get black color. Okay, I hope this makes sense, because dekhen, black color only contains 3 type of dyes. If we mix this one right here is the blue dye, and these are 2 other dyes. So if we mix these 2 other dyes with this blue dye, we can get black ink. So these 2 dyes together are present in orange ink. Okay, in orange ink. So basically, if we mix the orange ink with the blue ink, we have all 3 dyes to make the black ink. Okay, do you get it? If we mix the orange ink, which is the upper 2 dyes, and the blue ink, which has the lower dye, we can get the black ink. So the ink which could be mixed with the blue ink is orange ink. Reduce the color of one dye that is contained in all 3 of the orange, green and black inks. Okay, all 3 of, we have to check, orange, green and black. Okay, what's common in all of them? This middle one is not present in green, and the lower one is not present in orange. So this upper one is present in all, and this upper one is yellow ink. How do I know? Because look, yellow ink only contains this thing. So this one is yellow ink. So you have to write it's a yellow ink. Okay, moving on. These are really nice questions. Okay, these chromatography ones where they ask about the dyes and everything, they're really kind of you just have to use your common sense. You don't have to know any chemistry for the ATP paper. I guarantee you this, that only if you guys follow the steps, the procedures and everything, you can ace above 30 in your ATP. Chemistry, there's no chemistry except if there are moles involved, then you have to just work out them, but even then the steps are given. So it's just about I guess following the steps. A student investigates the temperature change when aqueous copper to sulfate reacts separately with 2 different metals, zinc and iron. So we have this substance that's reacting with zinc and then iron, and the student basically investigates the temperature change. The student does 2 experiments. Experiment 1, use a 50 cm cube. Okay, I know this because I've solved a lot of ATP papers, and now I'm proficient at this, that I know whenever they've given me a long paragraph like this experiment, always it's gonna be that there's gonna be a mistake in this. I don't know what's the mistake right now. When I'm gonna read it, I'm gonna read it in such a way that I identify all the mistakes and errors in it, because I know this is definitely gonna be a mistake which I'd be later asked to figure out, because after solving a lot of ATP papers, you are, I guess, familiarized with the pattern of an ATP paper. So I know right now that while reading it, I have to identify all the errors which I possibly can. So use a 50 cm cube measuring cylinder. Whenever you're using measuring cylinder, always remember that measuring cylinder can never give you exact amounts. Measuring cylinder only gives you approximate amounts. So this is my first mistake, that I'm using a measuring cylinder which is going to give me my approximate values, not my fixed values. To pour 30 cm cube, okay, instead of measuring cylinder, I could use a burette. Why? Because burette would give me more accurate readings of aqueous copper 2 sulfate into 100 cm cube beaker. Now listen. This 50 cm cube is just there to confuse you. You know why this 50 cm cube is written here? A 50 cm cube measuring cylinder to pour 30 cm cube, to confuse you guys, to confuse those people who don't basically read this information and they just look at the values 30, 50, 100. That is to confuse those people. A 50 cm cube measuring cylinder simply means a measuring cylinder that has a the max value of 50 cm cube. So that's simply what it means. So don't be confused. Use a thermometer, and same goes here. 100 cm cube beaker simply means a beaker with a max value of 100. Use a thermometer to measure the temperature of the contents of the beaker. This is the temperature at time 0 seconds. Add 3 grams of zinc powder to the beaker at the time start the stopwatch. Using the thermometer, continually stir the mixture in the beaker. Okay, why are they asking you to stir the mixture? So that the contents or the heat is equally distributed. Okay, You need to know each and every step. Why are we doing this? Why this is not a good thing? Everything. Why are we gonna use same amount for both to get accurate results, to get fair results? Measure the temperature of the mixture every 30 seconds for 210 seconds. So how many times are going to measure? 7 times. After you measure 7 times, it's going to be 210 seconds, because it's simply table of 3 are 37 times 210. Empty and rinse the beaker with distilled water. Repeat experiment 1 using 3 grams of iron powder instead of zinc powder. You're using the same amount. Okay, now they're gonna ask for complete table 2.1 by using the thermometer diagrams and calculating the temperature change from the temperature at 0 degrees Celsius. Okay, we just have to calculate the temperature change. Over here, let's first write down all the thermometer readings. I guess this is 30, 31, 32, 33, 33.5. So it's 33.5. Now this one is 30, 35, 36, 37, 38. This one right here, this one is 40, 41, and this is 41.5. Now the examiner is very clever. He gives you in 0.5. You know why? Because I've done a mistake, and I'd like you guys to figure out my mistake. I'm showing you my numbers and I've done a mistake. I'm gonna tell you my mistake at the end. 40, 41, 42, 43. Okay, 40, 41, 42, 43, 44. Now 40, 41, 42, 43. And now this is 40, 41, and 42. Okay, what is the mistake that I have made in all these numbers? There's a very big mistake. The precision of the thermometer is too near a 0.5, and I have missed a 0 over here. After decimal, I have to put a 0.0 over here, a 0.0 over here, because look, the precision of the thermometer, if I don't write 0.0, my marks are going to be deducted. So it has to be like this. And I have to write the temperature change since time. So I just have to subtract my two values, this value and this value. I have to subtract this value and this value, and then I'll continue with all the values like this. So 33.5 minus 24. 33.5 minus 24, and it gives me 9.5. So my temperature change over here is 9.5. I have to do this for all. So now 24 minus 38 minus 24. 38 minus 24, that gives me 14. 41.5 minus 24 minus 24, and that gives me 17.5. Put a 0, don't forget to put a 0. Okay, 43 minus 24, and that gives me 19. 44 minus 24, 20. 43 minus 24, 19. I know that these are pretty easy calculations. All of us can do them by hand, but please don't try. You know why? Because it's not worth losing your marks when you have a calculator. Don't try, don't even try, because we are humans, we can make errors. So please don't try it by your hands. Now let's fill out this 20, 21, 22, 20, 24. Okay, 25.5. This one right here is 26, 27. This one right here is 25, 26, 27, 28. This is 28.5. And this one is 29. Okay, and this one right here is, I believe, again, 29. And now what we have to do is, because we have to calculate the temperature change since the time 0, so what we have to do, we just have to subtract the initial temperature, because which was at 0 times 0, from our the next temperatures. Okay, so it's gonna be 24, it's 2.0, that's gonna be 3.5. Let's use a calculator because I don't want to risk anything. It's 3.5. I know I can do it mentally, but let's not. 5. If you're short of time, then try to do it mentally, but if you have time, then okay, we're done with this. Now we have to complete a suitable scale on the y-axis and plot the results for experiment 1 for both and experiment 2 in figure 2.1. The point at 0, 0 has been plotted. So that means we have to start an axis from 0, 0. We have to draw two curves of best fit, and both curves must start at 0, 0. Okay. So we have to start from this point, and we have been given with the time, and we have to figure out the temperature change, and we have these kind of values. So we have to plot the temperature change since time 0, and we have the lowest value that we have is a 2, and the highest value that we have is a 20. So from 2 to 20 we have to plot a graph for temperature change. Don't consider they're asking for temperature, no, what they've asked for is the change. So we have to plot the change from 2 to 20. So let's figure it out. 5, 10, 15, 20. No, this can be 5, this can be 10, this can be 15, and this can be 20. I guess that's the best thing that we could do. Now let's plot. So we're done with plotting all the values, and this has given us our 5 marks. Okay, extrapolate the curve from experiment 1 in your graph in figure 2.1 to reduce the temperature change since time 0 seconds in the experiment 1 after 240 seconds. Okay, show clearly on figure 2.1 how you worked out the answer. So we have to extrapolate the graph for experiment 1 till 240. So how is the graph gonna go? It's gonna move. So this is the graph, and now it's gonna simply move down with the same gradient. I guess this, not this, this looks like a decent curve. So at 240, so now let's just figure it out. We have to show this is 210, this is 220, 230, and 240. So this one right here is the line for 240, and this exactly comes out to be on, let's check out, this is 15.5. so the temperature change is going to be 15.5. State which experiment 1 or 2 is more exothermic. Obviously we can see the temperature change in experiment 1 is far more greater than the temperature change in experiment 2, so obviously it's gonna be experiment 1, and the explanation is gonna be more temperature increase, or you can say the more temperature rise, the more temperature change. Okay, predict the temperature of the solution in experiment 1 after 3 hours. So after 3 hours, it's basically gonna be again at, in experiment 1 they've asked, it's gonna be again 24, because 24 is the room temperature. So it's gonna be again come to the room temperature, which is 24.0 after 3 hours. So it's gonna be 24.0. Explain why using copper container instead of a beaker would not be an improvement. Because when you are dealing with heat, experiments that involve heat, you never use copper. You know why? Because copper is a good conductor. It allows heat to escape. So you cannot measure the increase in temperature. So the answer is going to be that copper is a good conductor, so it's going to allow heat to escape, which is not what we want. We need to trap heat. Describe 2 changes to the apparatus that will improve the results of this investigation. For each change, explain why it will improve the results. Change 1 is going to be that we're going to use a polystyrene cup. Why? Because polystyrene is a good insulator, and we need to trap heat in such experiments. And always remember that when we are doing an experiment like this, we always try to keep the things, we try to insulate it. Either we use a polystyrene cup, try to insulate it so that we can prevent the heat loss from the beaker. And change too can be something very visible that we tried to figure out, because we have to describe two changes that will improve the results of the investigation. Well, reading this, I always told you that they're going to ask for the changes and improvements. Over here, we figured out that using a measuring cylinder was not good to pour 30. We could use a burette. So that's what we're going to write, that instead of, while reading, just underline all the mistakes that you find, especially the measuring cylinder mistake is very common. Change 2 can be using a burette instead of a measuring cylinder. Why burette is more accurate? It gives accurate reading instead of a measuring cylinder. Explanation is going to be that a burette is more accurate, going to give you more good results. Okay, moving on. A student tests two substances, solution A and there's a solid B. Tests on solution A. Solution A is aqueous chromium 3 chloride. We have a chromium ion in it and we have a chloride ion in it. Okay, a student divides solution A into 3 approximately equal portions. Complete the expected observations. To the first portion of solution A, the student adds aqueous sodium hydroxide dropwise until it is in excess. Observation. Okay, we are adding sodium hydroxide dropwise until in excess to solution A. So what's going to happen? Chromium ion. Yeah, I believe this question is simply copy pasting from this table below. Okay, go to chromium ion. I'm not even going to solve it because it's that easy. Anyone can do it. Chromium ion, test for it, green precipitate, effect of aqueous sodium hydroxide, and then soluble in excess. So just copy paste what's written below. I won't waste my time on just copy pasting. Then secondly, to the second portion, the student adds 1 cm cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. So basically we have a chloride ion, and when we add barium nitrate to it, we have a chloride ion in the solution, and when we add barium nitrate, BaNO3, what's going to form? Barium chloride, BaCl2. And barium chloride is soluble, it's not insoluble. Many people think that barium chloride is insoluble. It's sulfate, it's barium sulfate that's insoluble, not barium chloride. So there's going to be no change. Okay, to the third portion of solution A, the student adds 1 cm cube of acid followed by few drops of silver nitrate. So now we have a chloride ion, and what we're doing is that we're adding chloride ion and we're adding silver nitrate to it, AgNO3. So we're going to form silver chloride, and silver chloride is insoluble. So the observation is going to be a white PPT, which you can copy from below. Again, we have all the tests, and you just have to copy paste. This entire question is a copy paste question. Describe how to carry out flame test. How do you carry out a flame test? Firstly, you have a wire that you dip into the solution. Then you just put the wire on a non-luminous flame. What is a non-luminous flame? It is a blue flame. Non-luminous flame. Basically, you might have seen yellow flames and blue flames. So non-luminous flame is basically your blue flame that you get by adding oxygen to by opening the hole in the Bunsen burner so that you can get oxygen. So non-luminous flame is basically a blue flame, something like this, and it is a very intensely heated flame. A yellow flame is a lighter flame. Identify the ion that is tested for in test 4. Easy peasy. Damp red litmus paper remains red. We don't have to write about the results. We have to check which ion. We have to warm the solution from test 3. In test 3 we added sodium hydroxide, and now we're checking the gas given off with a damp litmus paper. So obviously that's for ammonium ion. For ammonium ion, what we do is we add sodium hydroxide and then test the gas given off, warm it, and then we test the gas that's given off with a litmus paper. Identify the two ions which are in solid B. Firstly, we had a red colored flame. So a red color indicates a lithium ion, and secondly, we have a white precipitate formed over here when we added barium nitrate. So that's going to be obviously for a sulfate ion. So we have a sulfate ion and a lithium ion. SO4 2 negative, Li plus 1. Moving on to our last question, which is the most interesting question over here. That metal spoons can be electroplated with silver. Okay. Describe how a metal spoon can be electroplated with silver. Include in your answer how could you determine the mass of the silver electroplated. Okay. And you are provided with solid silver nitrate. Okay, solid, we have silver nitrate, we have a metal spoon, we have a piece of solid silver, we have distilled water in common laboratory apparatus. You must include a diagram in your answer. So firstly, I believe that to questions like this, the biggest thing is that you draw it stepwise, like I have drawn it over here. So what we're going to do is that we had solid silver nitrate. So what we're going to do is we have to make an electrolyte out of it. Why an electrolyte? Because look, the metal spoon has to be plated with this piece of silver. We have silver, we have metal spoon, and now we need an electrolyte. Electrolyte is basically the solution in which we're going to conduct the electrolysis, and obviously it has to contain ions. It cannot be a solid. So what we're going to do is dissolve the solid in distilled water. So what we're going to do is, firstly, you need to dissolve the solid to make a solution, as electrolyte cannot be solid, so we're going to dissolve it. Secondly, since we have to calculate the amount of silver that is deposited on the spoon, we calculate the initial mass of the spoon. Then we conduct the electrolysis. In the electrolysis, even if you just draw this diagram and explain the steps bit by bit, not in detail, only bit by bit, you're going to get the marks. Just the diagram. Okay, then you have the spoon, you weigh the mass, then you have make the spoon the cathode, the solid silver your anode, and your silver nitrate as your electrolyte. Conduct the electrolysis. After electrolysis, since some electrolyte might be present on the spoon, wash and dry the spoon, as some electrolyte might be stuck. Then weigh the mass of the spoon again, and finally subtract the initial mass of the spoon from the final mass. You're going to get the mass of the silver that is deposited, and that is how you're going to simply conduct it. As easy as ABC. If you're not sure with it, you can just read these steps as well. I have written them. That firstly we have to dissolve the solid silver. That's all, but I've just showed you in the diagram. So these are the four or five major things that you have to do, and then explain these things on the lines above, and that's going to give you your 6 marks for the question. But important thing is, then don't miss out that you have to place your spoon at the cathode, because the thing that has to be electroplated is always on the cathode, and your solid silver at your anode. So these are the important things, and I hope you liked it. So please consider subscribing to the channel. That's going to mean a lot.